from Enterprise DevOps. I hope everyone is doing great. So today the thing on which we will be working on is Kubernetes. It's a very important topic. Everyone, all the almost all the companies, enterprises, their applications are running on Kubernetes. So in this video, we will discuss why they are using Kubernetes, what are the main reasons, and what are the benefits, and the most simple way how to implement Kubernetes or how to use Kubernetes. Even if you don't have basic knowledge, it's basic knowledge is enough for you. Let's suppose if you have basic knowledge for Dockers, even if you don't have, this tutorial will work for you. You will understand all the concepts, components of Kubernetes. You will know how to deploy applications, what are the tools which is handy for you. You don't need to go through the core concepts. Like in this video, we will be mostly focusing on the practical side rather than the theory side. So we will be working on the tools that can help us to increase the productivity and all the resources which are important to work with, and we will understand what they are and how to use them in most easy way. And then we will take some sample application. We will just use it and deploy it to the Kubernetes through different methods. So let's get started. Uh, let's take some time for the history, like what's the reason that companies they move to Kubernetes. So at start, all of you know, every application is monolithic. Monolithic application mean you have the APIs there, you have the database there, you have all of the functionalities from payments. All components are compiled together. So this means that not more developers are working on the application. If there are more developers working on the application, there might be a chance of discrepancy and duplications and this stuff. So that is monolithic application. If there is one component of your application is down, the whole system is down. So after some time, what happened? The company they start moving from monolithic application to microservices. So what are microservices? Microservices just a fancy term, you can say. Basically what it just divide the applications into multiple components. Let's suppose you have one application here, monolithic application, that is a recruitment website that have pages for job applications, job vacancies, and recruiters. Basically 3 modules in one application. And if one module is not working, your whole application, your whole system will be down. That's the reason they move towards microservices. So what will happen in microservices? Your main product will be the same, like recruitment website, but inside that product, you will have bunch of multiple applications. Like you have a separate application for recruiters, no matter it's written in Java, Go, Python, any language. And then you have a separate application for job applicants and job vacancies. These 3 applications, they are independent of each other. So if some application, one of the application went down, the other both applications will be working. This means your website will still be alive. There will be no downtime for the customers until they will use that specific recruitments or the job applicant or job vacancies module in your application. Okay, so this is microservices. The concept is simple. You break down your complete application into small applications with the freedom of platform, freedom of language, whatever language you are using, and the better, you can say that better coding, better teams, efficiency, all of that, everything is included in microservices. Then after that, what's the next step? The teams they need to deploy their microservices. So that, let's suppose if we have one application that is consists of 3 applications, so the team they need to deploy these 3 applications in order to complete our application, right, for the recruitment. So that time what happened, a new term is came, like Docker. Docker is you can say that it's a simple small version of virtual machine or small version of environment It's not a physical, it's just, you can say that it's uh, just a normal environment, and it's you don't need to work on the physical layer on this stuff. It's a virtual, everything is virtual. So you can say that what is Docker? Docker is a virtual environment, and it is independent of platform. No matter your application is built on Windows, Mac, Linux, it will work on Docker for all of the environments. So Docker means it's a totally independent platform in terms of OS. So at that time, what happened? Let's suppose our we have multiple team of developers. Some developers they build their application on Windows. Some developers they build on Mac. Some build on Linux. But normally, what happens whenever all of these three developers combine their applications, it doesn't work. Why it doesn't work? Because all of these three developers they have different platforms. One is working on Windows, Linux, and Mac. So there is a platform dependency, and it's not available for all of the platforms. So to overcome this, a new solution came called Docker. So what Docker do, it will create a virtual environment so that no matter wherever you build your application, it will work on that environment. So you have a Linux application, you have Windows, every application, it will work in a Docker environment. It's a virtual environment with all the dependencies included which is required to run your application. So now you understand what is Docker. So let's suppose in this case, we have a recruitment website. What the developer will do, they will build the three versions of application, basically three sub applications, one for recruiters, jobs, and job vacancies. So they build their Docker images and they push the Docker images to Docker Hub or any registry. Okay. And then the problem is solved. They can run their Docker images and their application is live. But the problem with Docker is mainly thing, first thing, it's there is no, you can say that the auto scaling stuff. Like let's suppose if one of your application get restarted or crashed, the Docker will not understand the application is crashed or it's not working. Docker will not do anything automatically. So you need to monitor your all of your applications in Docker by yourself. So to overcome this stuff for high availability and auto scaling, these kind of features, developer first features, a solution came called Kubernetes. So what is Kubernetes? Kubernetes is just basically an orchestration platform. What this means is that you have a Docker image for any application, and you can then deploy that application to Kubernetes platform. Kubernetes will take care of their application by making sure the application is available every time, the application accessible, configurable, and logging, monitoring, you can name it, everything it has. From authentication to logging, monitoring, everything what an enterprise level company needs, Kubernetes will support all of them. And with a lot of open source tools that can help you to build better applications, better systems, tracing, all those kind of stuff. So Kubernetes, what it's doing, you have a Docker image, a small application, you will run on Kubernetes. Kubernetes will make sure that this application is available no matter if the application get crashed, stopped or something. Kubernetes will make sure to make this application available all the time. If the application crashes, Kubernetes automatically restart the application. If there is a more traffic or more load on your application, Kubernetes will automatically auto scale the application based on the need, based on the utilization. So you don't need to go and check manually the matrices for your application or load on your system. Kubernetes will handle all of them. Auto scaling, replication, bunch of things. We'll discover it. The main reasons, sorry, main reasons why companies, not only enterprise, every company, they are adopting Kubernetes for their business. You can, it's first thing is productivity, and then you have a lot of open source tools that can work directly on your Kubernetes platform, which can improve your profitability, productivity, logging, monitoring, tracing, bunch of things in terms of security also. And no matter Kubernetes is built on Golang and it's a lightweight solution, important thing is automated provisioning, like we discussed before. Kubernetes will make sure your application is alive. If there is more load on your application, it will make sure that it will auto scale your application by itself when there is load, and it will also downscale your application when there is no load. So what this means, Kubernetes will make sure that we will be using an optimized platform to cut down the cost, rather than you spin three virtual machines of 1 TB and 16 GB or more RAM, and you are not consuming, and you are normally consuming 15%, 20%. So rather than that, we can have a one cluster of Kubernetes, which will make sure that all of your three applications are working on the same cluster, and Kubernetes will make sure that these applications can be auto-scaled based on the need. Not every time. It will not. You can say that it will not leave the resources open so that your billing ping you on. It's properly optimized. So whenever you need more resources, Kubernetes automatically will allocate more resources to your applications. And then efficient IT management. We'll get to know when we will deploy this application. Okay, so we will not be going in depth theory, just most likely we will be focusing on the practical side only. So, but there are some few stuff which I think it's important to know what's the architect and how it's working, and high level. So in Kubernetes, you can say that you have one master node. One master node means there is one virtual machine which is master. What this virtual machine is doing, it will connect to other virtual machines called node. So you have as much as many nodes. It depends on your workloads, your applications, number of applications, all those kind of stuff it will come. So normally what happen, what what will master node will do? It will just make sure everything is working fine. It will cross check your applications on the nodes, scaling, auto scaling node, these kind of all stuff. Master node, it will take care of them. Other than that, you don't need to focus more on the architect level. You can say that there is a master node and there are a bunch of worker nodes. Master node will control all of the worker nodes, all of the applications, make sure everything is working fine, nothing else. Okay, this is the important thing which we need to see. So these are all the resources which are the important one in the Kubernetes. So let's start one by one. First, we will discuss in sorry, in theory what they are, and then we will go on practical side to implement every part one by one with the simple manifest file. We'll go through that one. It's much easier than theory. So number one, we have ingress. You can say that ingress is just Nginx server or Apache server or any web server or any proxy server which is listening for external traffic. What this means is, let's suppose you have one application like this one recruiter application, but you want to make this application public for your customers. Let's suppose on www.recruiter.com. So what will happen when someone type this address? There is some stuff on the DNS side. So whatever DNS you are using, like Bluehost, GoDaddy or DigitalOcean or AWS Azure, Cloudflare, anything that will work. What you need to do, you just need to point the CNAME or A name record in your DNS to your Kubernetes server. It will give you a public IP. So what will happen when someone types www.recruiters.com? The traffic come here on the ingress side. This ingress is part of Kubernetes. So what this ingress it will do, it will see what's the host address, like what client, what they are looking for, what's the domain. Let's suppose it's www.recruiter.com. So ingress, he will know, okay, I have one service which is responsible for this host name. So ingress will forward the traffic to our service. What is service? You can say that the service is the main entry point for all of your pods. We'll see what is pod, but you can say that service, it's the entry point of communication with your application. So ingress, it will forward the traffic to your service, and your service is responsible to communicate with your applications, send the request, get the response back, and send the response back through ingress to the customer. These are 3 points: ingress, service, pod. Okay, make sure one thing: whenever you want to communicate with any of your application, you will have a service for that application. Let's suppose if you have 3 applications, you will create 3 services for 3 applications, so that the service, it will communicate only with that application. One service, one application. It will work like this. We'll see in practical, that will be more helpful. Just I want to overview what are the components of Kubernetes, so that you know. Okay. Third one is the pod. So what is pod? Pod is, again, it's a virtual environment, a virtual space, a virtual environment which is properly isolated. It doesn't have anything with any other environment. It's a proper virtual environment. And inside the pod, the Docker is running. The Docker containers, if you run the application through Docker. So in Kubernetes, inside the pod, the Docker containers are running. There can be one Docker container, there can be two, three, whatever, like how many Docker containers you can put it there in one pod. So normally what will happen, one application have, each application have their own pod, but in one pod you can have multiple Docker containers. For example, let's suppose you have one application for job vacancy. So your job vacancy Docker container is running here, but you can put more containers here also, which will run with the same pod. Let's suppose you want to run one container for the logging or for the monitoring, let's suppose Prometheus or any tool. So you can run that pod also along with your job recruiter or job vacancy pod also. So what this mean, in one pod you can have multiple containers. We'll see what's the how we will declare and everything. Okay, that is pod. Then you know one thing, all of our applications, they need some sort of configurations, environment variables, some config files, or some secrets, some sort of authentication, some credentials, API tokens, anything. So in Kubernetes, we declare those things in this part. There is one resource called config map. So what is config map? You can store all of your configuration for that application in the config map, and then we can use that config map in our application, in our pod, like sorry, by environment variables, by file, by we will see what are the different options. But you can say that if you have a general configuration for your application, you can put in config map. And make sure one thing, whenever you will update the config map, some value or something, your application will automatically restart it. Let's suppose you have one config map for 100 applications. Okay, you will not go to each application and change that config or something. You will just come up here and just update the value inside this config map of that parameter. So it will automatically update all of your applications. The same stuff is with the secret also. So let's suppose you have some sort of authentication token, like the some stuff which is, you can say that for the security stuff, because everything in the secret it's encrypted in Kubernetes. So we will make sure that whatever we store, whatever some, if there is some config or some environment variable or anything which holds some confidential information like credentials or anything, that we will put in secret. And again, the secret can be mounted as environment variables, volumes, different options we have. So if you need to configure your app, secrets, any kind of stuff, you will focus on this thing. Okay, moving forward, we have, okay, all of our applications, not all, but some of our applications, we need to store their data, right? Let's suppose you have one application for Postgres. So user connect with Postgres, or your application, other application connect with Postgres, create some tables, everything, and it's inside the pod. Let's assume you have only pod without any volume. So once the pod is deleted, or yeah, you terminate the pod, all of the data inside that pod, it will be gone, because we are not persisting that data. Mean we are not saving this data somewhere in our system or cloud or anywhere. So to protect our data, like to persist our data in Kubernetes, we have two terms: persistence, volume. What it does, persistent volume is just nothing. You can say that, let's suppose if you have application for recruiters, you can say, okay, I need 1 GB for my application. What this mean is 1 GB you need persistent volume of 1 GB. That's all. That's all. It's persistent volume, persistence volume claim, storage class. We will see how they work. Most of the time you will be only working with the PVC and storage class. Storage class is, you can say that it's used for dynamic provisioning. Like it's something easy to use. You can just say, okay, in PVC, okay, I need 10 GB for my application. The storage class will automatically generate a volume of 10 GB and give to your application. That's how they work. If you will not use storage class, then you need to go through and create the persistent volume by yourself. By yourself mean you can specify a specific host directory where you want to create this volume on the server side, NFS options, S3, and other bunch of stuff. But now what companies are using and what we will be use also, we will use just persistence volume claim with the storage class. So let's suppose if you will check any of the Kubernetes cluster, there will be a storage class already. If not, you can just create one and then use the PVC persistence volume claim to create resource for your application. We will see in practical how easy it is. Okay, on right side there are bunch. Okay, this is board, right? Now if you will see the right side, these are some types of you can say that are deployment types, like how we want to our application in Kubernetes. First option is a normal deployment. What deployment mean? That okay, we will deploy one application with replicas, and what it will do, let's suppose if you will create a one deployment with replicas, it will create a pod. If you will put one replica, it will create one pod. If you will put two, it will do two. If you will put three, it will create three pods from deployment. So you can say that your entry point is this thing. What you need deployment. When we use deployment, So we use deployment normally when we want auto scaling, number one, when we want replicas of our application. Replicas mean three instances of application is running. Normally this thing. And it will make sure, let's suppose if your application get crashed or anything, the deployment will make sure to run those replicas which you mentioned. So you don't need to be worried. It will be auto scaled as well also. Second one, we have stateful set. Stateful set deployments, both are same. As such, there is nothing changes. But one thing is changed. Just put this one thing in your mind. Whenever for you are dealing with data, like you want to process data, or there is something going in your application and you are storing data in your application, go directly for the stateful option. Because in stateful option, when you mount your application to a persistence volume, let's suppose if you delete your application or anything, your volume, it will be still there. It will not never be deleted until you want to delete it. But in the deployment, if you will mount the volume, but when you delete your deployment, your volume will also be deleted. That's the main difference. So you can say that if your application, it's not dealing with data, it's a stateless application, you can use deployment. If your application is dealing with data, like Postgres, you have application of Postgres or any database, you can go with stateful set. Okay, all of them, whenever let's suppose you create deployment, stateful, or any of these option, it will go and create the pod, and you already know what is pod. So we have one type for job. Let's suppose if you want to run one type job, you can use this job type. If you want cron jobs, you can use this type. And there is one type is daemon set. So what is daemon set? Daemon set is like you have, let's suppose, one application and you want to run this application on all of your nodes. That is daemon set. Daemon set means make sure that your application is on all nodes. Mostly daemon sets are used for monitoring purposes, like you want to get matrices from all of your nodes. So daemon set will do that stuff. That you will make sure that the application which you are deploying, it will be deployed on all of the nodes. That's all. That's the thing for the theory. Now let's go and do some stuff practical. Okay. So what you need? You need to install two tools. One is you will go and download Docker Desktop. On any platform, if you're using Windows, Mac, Linux, any platform, you can just go and deploy Docker Desktop, because with the help of Docker Desktop, we will be initializing or spinning up a Kubernetes cluster in our local system. If you don't want to use Docker Desktop, you can use sorry, Rancher or K3s, anything which can run Kubernetes in your local system. That's all. We are using Docker Desktop for simplicity. Second thing, you need to install this tool, Lens. It's Lens application. You will install it, and I will tell you what we will be doing with the Lens and how it can help you. Third thing, I open some links. You need to open this link with you, Kubernetes.io docs home, for the documentation of the Kubernetes. Because see, everything it's in the documentation. So we'll just come here, whatever we need. You don't need to memorize anything. Whatever you need, just you need to understand the concept. Okay, these are the things which I explained you already. These are the everything what you need to know. Other than that, it's not mandatory. It's not a show blocker. So this documentation, it will help you for everything. You want to create board deployment, anything, it will help you. Second thing is kubectl cheat sheet. This will give you all commands, everything, whatever it's needed. We'll not be focusing on this one. This, you can say that it's just a tip from our side that you should have this link with you if you are using CLI. Okay, so I download the desktop and Lens also. What's the first thing you need to do? Just 1 minute. Okay, so what you will do, you will open your Docker desktop. Then after that, you will go to settings, and under the setting just enable this option. Once you enable this option, and you will find an option for save or apply. Once it's done, what will happen, that Docker, it will create a Kubernetes cluster for you, and you can see from here it will take maybe 1-2 minutes or 3-4 minutes, and then you will see here, okay, Kubernetes is running. That's all what we need from Docker, nothing else. And one more thing for surety, you can come up here, and under the Kubernetes you can select your Docker desktop. You will not have these other options, but in case you have, you can just go and select your Docker desktop. This is the context. Context means we want to connect with this cluster, my local cluster. Okay, so once your Docker is up and running, your Kubernetes services are running, will come up to Lens. So you will open this tool Lens. Then after that, what we'll do, you will click on catalog clusters, and then you will find your Docker desktop cluster here. You can double click on it. So it's as simple as that. You have access to your Kubernetes cluster, GUI access. You can see what's inside your cluster. And we will use this tool to go through all of our deployments, applications, services, volumes. We will create everything from here. We'll check the logs. We will execute inside our applications. We'll get the shell access. Everything you can do from GUI. You don't need to be more professional on kubectl commands. That's not needed. CLI to manage Kubernetes. If you have Lens, you can manage all of your applications, Kubernetes, debug, log, everything from here. So once you connect, you can just come up here and add this to your hotbar so that it can be accessible here. Okay, so yeah, let's start the stuff now. Okay, just 1 minute, please. Yeah. So let's see what's inside our stuff, our cluster. If you will click on nodes, it will give you information of your nodes. Currently, we have only one worker node. You can see here, we have only one worker node. It will give you the node version. It can give you the CPU, memory, everything, utilizations, and it will tell you what applications are running on this. And you can see all of the events here for debugging purposes. You don't need to go to your kubectl get events and this kind of stuff. No need. See, we don't need to learn this stuff for now. Okay, then if you will come to your workload windows, workload is everything you need to understand. Workloads like this is the environment where all of your applications are running. So if you will click on overview, you can see that you have 9 pods are running, one deployment is running, one daemon set is running, 0 stateful, one replica set. Replica set and deployments both are same. You can say that. Jobs, cron jobs. Okay, then if you have some events, you will find it here. Okay. First menu is ports. Remember we discuss here ports. This port. So first thing, let's see what is port. So if you will come up to menu here, ports, you can see all of the ports. Ports mean application. All of these applications are running here. You can see that, okay, this is the application name. You can see here containers. There is only one container running in this port. If there are multiple, you can see here multiple boxes. How many times this application restarted. This app, see, you can see here, this port is controlled by what? By replica set. See, this port is controlled by what? Deployment, stateful, job, replica, daemon set. So you will find this information here, and you can see here currently this port it's running on which one, which node, first node, second node, whatever the things. From when this port is running, what's the status? Okay. Now if you will, okay, just let it basic, then we will create our own stuff and then we will see what are the options we can need. And if you will click here, you can see all of your deployments. What is deployment? Deployment, we will give the file. Okay, let's suppose we want to deploy this application with this specification. Deployment will create the ports. So you can see here the deployment name is core DNS and there is a replica set of 2. It makes sure that this application have 2 replicas. And if you will come up here, you will see here core DNS. This is the first one and this is the second one. Both are running. Again with the daemon set. So daemon set, as you already know, what is daemon set? It's make sure that the application it's running on all of the nodes. You can see here. It's running on all of the nodes. Then you have stateful sets. Currently there is no replica sets and daemon set and sorry deployments both are same. Okay, you don't have any jobs, you don't have any cron jobs. Okay, down on the menu you have config map. Config map, as I already told you, everything which is needed for your application, any kind of configuration. So you can see here there is one config map for cluster info. What's inside? The kube config file. Let's ignore what it is. You can say that some information here for the application. See, there is some information for the applications here. Kube proxy. Okay. On the secrets, you can see here some more. Let's remove them. So currently we don't have anything. Resource quota, limits. We can just ignore them for now. Okay. On under the network, what we have? Services. What I told you that we need a service to communicate with our application, our port. So you can see here there is one service. Let's suppose this one, Kubernetes service, and you can see here this service name is this one and it's connected with its endpoints. Endpoints mean, you can see this is the port addresses. Like this service is it is connected with the ports for the application. Once we deploy the service, you will understand more. I'm just going exploring you through the tool that what are the options available. Same, you have the ingresses also. Persistence, volume, also storage class. You can see by default you will have one storage class in all of the thing. Okay, that's all for now for the lens. So, okay, I want to just clear one thing. On the right side, you can see here you have the search and everything. This means that you don't need to use kubectl, get ports and labels and everything. You don't need to do this stuff. You can just come up to lens. You can search, filter, whatever you need. Let's suppose I need core DNS. See, it will show only code. Okay. So currently it is showing me all of my applications for all namespaces. What is namespace? So you can say that namespace it's again a virtual isolated environment so that You can have multiple namespaces. Let's suppose you have namespace for security. There is one namespace called security, and inside that namespace, you install or you deploy all of your security applications. Then you have one namespace for web, and there you deploy all of your web application. Then you have namespace for API. You deploy all of the APIs. So this will help developers, administrators, everyone to go to their namespace and see what's inside. It's easy for them to manage, to be honest. And then you will have some security controls, which maybe we can discuss later on. So before doing anything, now we understand, right? What are the key concepts, but we don't know how to deploy applications, how to create board, how to create deployment, stateful, all this kind of stuff. So we'll go and start with this one. Currently, I didn't come to my CLI. I am not using kubectl commands. Basically, kubectl is what? It's the CLI to manage Kubernetes. Let's suppose kubectl get namespace. Sorry, you can see all it lists all of my namespaces. So kubectl, it's the CLI to manage the Kubernetes. But we are not using CLI, we are using lens. Okay, you need namespaces, you can come down, you can click on namespaces. Okay. Now what I need to create a namespace for myself. Let's suppose for my web application. So I will come up here, add a namespace, web. Create a namespace called web. It will automatically create a namespace. You can see the namespace is created, and if you will go to ports, and from here you select your namespace now. Make sure to select your namespace, because namespace, we will deploy every application, everything in our namespace. We will not play with other namespaces. That is from core. Okay, now we have our namespace ready. Now what we need? We need to deploy this stuff, right? We need to see how to deploy. So we created namespace. You can create namespace from CLI also. For that, you know what to do. You can just go. You can just come up here and you can see the commands here or in the documentation. It's a simple commands. You can say that there are just some basic commands, maybe 8, 10, create namespace, create pod, create deployment, create this, create service, but you don't need to work on it. We will be using lens. So we created our namespace. So currently we have our namespace now, right? So let's suppose you have here we have our namespace. This is our namespace called web. Let's go and try to deploy one application directly. I am not talking about deployment stateful this. I just want to deploy my application. But I don't know how to deploy application. What is the syntax? One option is I will go to my documentation and I will search for create how to create port, and it will give me the YML and I will use that one. What's the other option? Other option is to use lens. So if you will see here down, you will find this plus button. If you will click on this plus button, okay, by the way, you can get the terminal session here also. So you can come up here and you can run kubectl commands also. See, so it works for you as well. Okay, you can click on new tab and you can click on create resource. Okay, all of them are resources, remember? So what I need to create? I need to create a pod, P-O-D. P-O-D. This is the pod. Okay, the lens, it give me everything what's needed to create a pod. So let's explore what are the options, what it is saying. API version, this is by default. We will not play with any of them. What are the things we will change? We will change the name. Okay, what you want to, okay, let's suppose this is my test app. Labels. Labels are important. We'll see it later why they are important, but you can say that all of your services, applications, their labels must match. Why? Because service will connect with your deployment or pod based on label. And then let's suppose if you want to do some sort of conditioning, some like high end stuff, concepts, that time you need to go and use labels. So just put in this mind, all of your applications, they need labels. Labels, why? Labels are identities. This is how one application or one service will connect with other one. Like the service will connect with the pod, volume will connect with the pod, something like this. So, okay, in labels, we have label for my role. Let it, okay. What's the container name? Container name, you know, right? In one pod, there can be multiple containers. So currently it's one container, but we can create multiple containers. Okay. What is my container name? Web. Okay. What application we want to run? Okay, we want to run Nginx normal. What we'll do, you will come up here, you will click on create. Okay, I did one mistake. You can see here the application it's not appearing here, right? Why? Because I didn't specify in which namespace I will deploy this application, right? So by default, all the applications go to default namespace. You can see here your application is running here. I will just come up here and delete from here, and I will go back to my again web namespace, and here I will mention this is one thing which you need to mention, namespace web. I hope you are understanding the syntax. It's simple YML. You don't need to change anything. You will just select a template and change the values based on your need. And then you will come and create. You can create and close also. You can close the window from here also. Now you can see here on ports you have one port, test app. Remember, this is the test app which we run, and the namespace is web, which we mentioned here also. Okay, and there is one container of Nginx server, right? And it's running now. What if I will click on this one? It will show me more information when this pod is created. What are the labels? Remember the labels? Annotations. What is annotation? You can say that annotations are, let's suppose if you use some Java framework or anything, remember on some methods, let's suppose in OOP, we have some methods where we define annotation up like void, required, regex. So that in annotation it's same here. So we will do later on, we will see how we can use annotations. Normally it's just for the functionality. Okay, I will give you example at the end how we can use annotation, but annotations it's just for this one for the functionality. Same, it's like the OOP. In OOP you have annotations for void, empty, regex, this kind of stuff. Okay, your application is running, it's running on this node, the pod IP. You don't need to care about these things because we will be using services. Okay, there is one thing, service account. You can say that it's just a matter for security. It doesn't have to do anything with us. We can ignore this, and conditions, everything is okay. Tolerations, we can skip it, no need. Okay, then it will show you all the information for your containers. Okay, so we have container name web, it's running. Image is Nginx. Image pull policy always mean every time it will pull the image. What are the ports? This is the port, remember? It's the container port. See here, container port, we define a port name, container port, TCP. Environment, we are not passing any environment variables, and we are currently not mounting any volume or anything. This is by default by Kubernetes. So it's by default mounting the service account. Again, it's relevant to security. What it does, it will help pod to communicate with the Kubernetes server, Kubernetes API server, or Kubernetes secrets or configs. Okay. Again, down in volumes, you have only just this one, which is by default, nothing else. Okay, events. What's happening with your application? Okay, successfully pulled the image. Container is running, everything is fine. What's the second thing you want to see? You want to check the logs for application, right? You will come up here, you will click on logs, and you can see all of your application logs. It's coming here. You don't need to go to CTL, kubectl, get logs for ports and this thing. You can see all of your application logs are here, right? What's the third thing you need? You want to go inside your application, right? You can click on shell, and now you are inside your Docker container. See, you are inside your container now. It's same like how you go inside Docker. What else? Okay. Now let's suppose if I want to delete this application, I will just come up here and delete it. This application is deleted now. I want to create this application again. I will just come down on the template and create it. It will again create my application. Now how I can use the application, how I can see. For that, in Kubernetes there is something called proxy forwarding, because normally all of your applications are inside a virtual environment. You cannot directly use this IP. If you will see one IP is here, you cannot use this IP because it's a virtual IP. It's inside the cluster. They are not reachable. So if you will use CLI, you need to go through some commands for proxy forwarding and this and this. Will not bother for that one. Lens will help us with this thing. You will come up here, click on the application, because we already exposed the ports, remember? You will come up here, you will click on this one just. So once you open, you can see here. You will refresh it, lens automatically to the port forwarding for us, and you can see your Nginx application is running. And if I will stop the service, it will go. That's how simple it is to deploy any application in Kubernetes, a normal one. Okay, what's the next step? Let's go and create a deployment. Let's see what's the difference. Okay, for that, what we need to do, you can just come up here, select a tag for deployment, and then you will find everything for deployment, right? What's the important thing? We need to mention namespace because we want to deploy in our namespace. This is the deployment name, labels, replicas. You can see here, replicas. How many replicas of our application needed? Replica mean it will make sure that every time there are 3 replicas of our application is working. You can configure auto scaling also here, that based on CPU utilization it will increase or decrease. That's also option in deployments. But currently we are using, okay, we need 3 replicas. Selector, I again tell you, remember, selector is important. It will select, this mean that this pod which we will deploy, they will have these labels, and these labels are matched with our application label. This is the label for deployment, and this is the label for our template. Template mean our ports. So down after this, you can say that after this we have port definition. Okay. Okay. Template metadata label. This will be same. You don't need to change anything here. You just, if you want to change something, you can just go and change the labels. Other than that, nothing will change. Important thing is here. Okay, what's the container name? Which image you want to run? And what are the ports you want to expose? I want to expose port 80. Let's go and create deployment. Let's see what will happen. See, I create a deployment. And what's happening now? So our deployment, it have three replicas, 1, 2, and 3. Three replicas mean three pods are running for our application. So we have one deployment. This is the deployment which is responsible for creating the pods. And we tell him that we need three replicas of our application. So it creates three replicas. If you will click on here deployment, you can see here the deployment name Nginx deployment pods 3 replicas 3. So it's based on us. If you want to create 1, 2, 3, whatever you want, it's on you. And deployment, it will make sure that we have three ports of this application. You can see here, right? And let's suppose if you click on any one, you can see all the details again. And if you want to access this specific port, you can come up here and you can use that port to access it. See, it's accessible. You want to connect with other one, this is the other one, right? Access it. You want to connect with other one, you can see all of these three are different ports. Okay, so what's the point that we have three ports? What's the advantage, right? Why we create three nodes, three replicas, and or why we need the replication? Why? Because see, when your customer connect with your service, with your application, it will not come and connect with that one application. Remember, any application which have less load or which is available to take connections, customer will connect with that one, right? For performance or for high availability, right? But currently, if you will see here, we created deployment and we expose the container port also, remember? But currently we don't have anything which we can use, and that thing, it will help us to consume all three of these ports, because I can only access port one by one, remember? But I want something like this which will automatically load balance my traffic, my request on all of these three roads automatically. I don't need to do manually this thing. I want something which will automatically load balance my request, right, remember? So for that, what we need? Remember, I told you there is something called service. Let's suppose if you have one port, this service is responsible for one port. If you have three ports, this service is responsible for all of these three ports, remember? So currently we have deployment, but we don't have service. Let's go and create one normal service. Let's create a new one, create resource. Let's write it service. Okay, don't need to change anything. Change the name. What service? What's the name you want? Let's suppose you will say it Nginx service. Remember the selector. Remember what I told you? Because selector is important. This service, it will check all of my pods which have this selector. It will match this one. Currently we have selector for app Nginx. So if I will put my selector app Nginx, what this service will do, it will select all of these three ports, because all of these ports have my label, remember? It's based on labels. It will match label to label. So I am creating one service with the selector, these selector for these application, and I want to expose this service on port 80, and my target port, what should be my target port? The same like container port, remember. Target port, this means which port inside your container you want to send traffic. So I want to send inside also 80 because my Nginx is inside running on port 80. So I will create a service. Make sure to add the namespace web. Let's go and create a service. So the service is created. Where I will find this service? Come up here, click on services. You can see here, this is the service web, and the service have one IP and the ports external IP. Again, the service it's also inside cluster. It's not exposed publicly. Only public you have ingress. Other than ingress, everything is internal. And again, if you want to use or expose any internal service or port, remember like in ports, you can use kubectl proxy forwarding, or you can come up here and you can forward the application from here. And you can see here, remember, what are the endpoints? This Nginx service have these three endpoints. These three endpoints mean it is automatically load balancing all of my traffic to all of these three ports. That's how simple it is to use Kubernetes for high availability, scalability, everything, because it will manage everything automatically. You don't need to do some sort of create some groups and this thing. It's everything is automatically managed. And if you will click up here, see, so for user it's requesting the same service. Remember, user is requesting same service, but this service it's connecting and it's load balancing my request to all of these nodes automatically. Sometimes my response is coming from port 1, sometime port 2, sometime port 3. Got it? That's how simple it is services. So you know how to create a pod, a deployment, and a service. Remember? Now, what's the next thing? Sorry. Let's go. Okay, let's suppose you want to create a job, cron job, daemon set. You don't need to do anything. Just come up here, create a resource, select what you need. Let's suppose you need job. Okay. What's the job name? Namespace. Container name, image, command. Okay. You can provide parameters for command also. Remember, see, if you will see the old template, you didn't provide command here because that command it's already in our Docker container image. It automatically runs. But let's suppose if you want to override that command, the override that command which is from originally from our Docker image, you can just use like this command, then the parameters. Also, you will find, let's suppose you want to see command, you can come up here and you can write command. It will give you with example also. So this is how simple it is. Let's suppose web, you want to run a job. Okay, what this job will do? Let's suppose it will do backups or it will ping something. That's how simple it's to create job. Let's suppose you want to create cron job. Cron job. Okay, what you need to change? Name, namespace. Okay, which container you want to run? What are the commands you want to run? That's all. Nothing changed. When you want to schedule. That's how easy it's to use cron job. So whatever you want to create, you will just come up here and create it. It's simple as that. Okay, we already created deployment, pod, service. Let's try and what's next we have? Let's create a stateful set. stateful set. See, okay, same stuff. Write the namespace where you want to deploy. In web, what should be my stateful set name? Let's suppose web stateful. Stateful mean it will process data. Deployment is stateless normally. Okay. What is the label? Don't mix the label with your old one. Let's change the label. Nginx stateful. Service name. You can put it or you can ignore it also. It's not mandatory stuff. Okay, again, how many replicas you want? 3. Okay, match the labels. Just change this thing to make sure everything is working. You don't need to modify, add anything extra. Just see, okay, this is the image. Okay, this is the port and see here now. The volumes came. Remember what I told you? Stateful set mean you want to process some data. You can do persistence in deployment also. But deployment normally it's not for the persistence because once you delete the deployment, all of your data which you process it's also deleted automatically. But in stateful, when you process some data, that data it will not be deleted until you want. So you can see here, okay, this is the normal stuff. Okay, you are running one container image for Nginx. This is the image name. This is the container port internally. You can, if you don't want to expose your container, you can remove this part. Volume mounts. Volume mounts. Okay, whenever you will see this sign here, this means this is an array. You can add multiple. Let's suppose in volumes, I want to add one more. I will do like this. More, do like this because this is an array. Okay, volume mounts. What it's doing? Name. What's the name of the volume? What you want it? www. Mount path. This is the path inside your container. This is the path inside your container that you want to mount the volume. Remember? So in the Nginx container, this path is mounted with our volume which we will create. Volume mounts www. And down there you will have volume claim templates. Name w. It should be same. Again, it's an array. You can have multiple. Okay. Name. Access mode, read, write once. Storage class name. If you sometimes you will have multiple storage classes. Let's suppose storage class fast, slow, AWS, Azure, this. So you can choose it here also. But if you will not specify it, it will automatically choose the default storage class. Okay. How much resource you want to allocate? 1 GB, 2 GB, 5 GB. Let's suppose 1 GB. Let's go and create it. It's resource is created. And you can see here. Now, it's trying to provision the volumes. It's waiting this image, it's waiting on the volume. So if you will come to ports, you will see web stateful 0. Deployments, okay, this one is other. Currently what we deploy stateful set, remember? You can see here. The port, how many replicas? 3 replicas. Currently it's under progress. And when you will come up here, okay, this port is initializing. You can come up to persistence volume claim. You will see here, remember this one? This is the volume host path, which port is using. And see, so what happened? This volume, persistent volume claim, it is managed by storage class host path, which is default class. So this storage class automatically create one persistence volume in our system. You can see here. We don't need to create this by ourselves. So storage class do this for us automatically. So whenever you need to use volume, you can see here, see, it's provisioning everything. And now if you will go back to ports, you can see here, okay, it's restarting. We will see what's the issue. Currently there are 2 replicas, but once they are up, you will find here 3 replicas here, because that is what we defined. We want stateful set for what? Stateful set of 3 replicas and with the specification, and we want to mount this volume from storage class. That's how simple it is to use stateful set. Let's go and see the logs. Okay, low VM. Okay, this is some issue with the Nginx container because of the volume mount, I think so. So let me go and just change it. Okay, one more thing. You can see here I change it, right? I change the mount path and I will go and create. Okay, and if you will come up here, there is this web stateful set, and if you will explore this one, how we can explore this application, this stuff. You can click up here, come click on edit, it will show you the definition file for this one. Just scroll down and from spec you can see here. Okay, okay, our configuration is updated. Everything is okay. Everything is fine. You got my point? So that is how you can come and create this stuff for stateful set. Whatever volume you want to mount, you will put the mount path for this stuff, and then you will change everything whatever is needed. Let's suppose if your current application is not running, you can come up here, check the log, fail to initialize Lua, Nginx failed to initialize Lua VM in etc nginx.config. So there is some problem with the image for in terms of Lua or some stuff under the temp directory or whatever it is. Okay, let's suppose you want to turn this, restart the deployment. You can come up and do the here. You want to delete this deployment, you can do it from here. You want to scale it. Scale it mean you want to downgrade it or upgrade it. You can use it from here. Let's suppose now I downgrade it to 1. What will happen automatically? It will go to 1 only 1 replica. So just the normal concept which you need to understand. Okay, and on the other side, it's everything, it's based on practice. The more practice you will do, the more comfortable you are. But this is the normal stuff. Let's suppose I am deleting my deployment and everything. Okay, I will come up here. Services, which service I created, I will delete it. Okay, persistence volume, you can see here. They are not deleted because they are from stateful set. Well, I will just give you one example in just a couple of minutes also. Okay, that's all we created manually. Okay, now let's go to our code editor, because code editor, it will help us to do some stuff. Okay, but you need syntax, you need the template. You will just come up here, select the template, copy it, and come up to your editor. I am using VS Code. You can enable these 2 extensions, Kubernetes port and Kubernetes template. This will help you for autocomplete, give you templates and much more. Okay, then you can, by default, once you enable the Kubernetes inside Docker, your kubectl, it will be there. But if it's not, you can download the kubectl from here. You can just go to Google and download kubectl, or you install kubectl or anything. Once your kubectl is done, You can, once you write this command, let's suppose get namespace, it will show you the namespaces. We will not be using any commands. I'm just clearing it. One command we will just use, that is kubectl apply minus f file name and then the file name, any file name. So when you want to apply or deploy any of your, let's suppose, resources application, you will use apply. You want to delete, you will use delete. Just these two commands we will be using here in this session. Kubectl apply to install, delete to delete. Okay, so how it will work, let's suppose I will create a new file called namespace.yml. Not namespace, namespace is already there. Let's suppose, okay, deployment.yml. From where I will find the syntax. Remember, here we have the deployment template. I will just copy it and paste it here. Okay. Currently, if you will see here, there is no deployment. Nothing running in our web namespace. Everything is same. I didn't change anything. So I want to apply this one. kubectl apply minus f. What's the file name? Deployment.yml. Press enter. It will create the deployment, and if you will come up here, you will see your deployment is running here. Now I want to delete this deployment. I don't want to go to lens and delete from here. I want to delete it from here also. So for that, use the same command. Just instead of apply, use delete minus f. It will create this deployment, delete this deployment. This is how easy it is. You just need to use these two commands. The template, you will get everything from here, or you can use extensions that will also help you to create something. So let's come and deploy one application, because in the application we need to configure, use some stuff. Remember, we need to use, in our application we want to use the PVC, like the persistence volume. How we can use volume? I give you one example, but we will use it with our application. We need to see how we can use config map. We need to see how we can use secret, how we can use ingress, everything. So syntax you can get for everything from here, remember? Okay, so let's go and create a port for our application. Let me put namespace. What's our, sorry, namespace is web, remember? Okay, our application name is, let's suppose, test, labels test, container name web app. This is the container image. You can use your images, remember? This is the env. This we will discuss later what we'll do. This is the container ports, restart policy, just that one. Simple, we didn't change anything. So I will create this port. The port is created. Okay, great. We'll come up the port and see if it's working or no. It's working. Okay, our application is working. Great. This is image from community. I didn't make it. It's from community. Our application is working. Great. First step is done. Port. We test it. Whenever you want to quickly test your application, you can just go and create a normal port. Don't go for deployment or replica set or stateful set. Just go and create a port. That's all. We tested our application is working. I will just delete this port. Port is deleted. I need to create deployment, but with this image. So I go to my deployment template, everything is okay. Okay, I will change the image here. Just change the image. nothing else. And if I want to see some specific environment env for my application, I will just copy paste now. Next step, I will explain you what are these things and how we can use it. Okay, container port I want to use 9000. Okay, let's go and create this deployment. Okay, deployment is created. You can see here all is good. Our application name is Nginx, everything is okay, namespace. Just we change the image and pass the environment variables. So when I come up here, I open the application. Okay, the application is working. Great. If I come to the other port, all of them are working. Okay, now let's create a service for them. Let's see how. Then after that we will come towards. Okay, let's first discuss the environment variables. So you know all of your application they need some sort of environment, remember? Sometimes you pass the environment variable to applications. Sometimes you read the configuration from some file, some stuff. So first step is with the environment variables. Let's suppose if I go open this one, scroll down, you will see here environment and you will see all the environment variables which are passing to this application. Again, if you will come, click on shell and you will write env, you will see all of the environment variables are here. And you can pass as much environment variables. Again, it depends on your application. This is how you can pass normal environment variables. Currently, we are not using config map or secrets that we will use later. We are just directly passing the environment. So this application have one environment variable for message. We can change it. Welcome. I hope you are getting my words. You will save it. No, okay. One more thing, yeah. And it comes here. Now I change environment variables, remember, or even in case I update my image tag and I want to do the deployment, I will not go and delete my old deployments because my customers are already using. Okay, so what I will do, I will just come up here and apply my deployment. You will see here, it will deploy my application one by one so that our application is highly available. So once a new version is deployed, after that it will terminate the old version. You understood? This is same for the stateful set, replication, replica set, everything. You can configure it how you want it. So this is how what this mean replicas, that when you will go for a new deployment or new pod or stateful anything, Kubernetes will make sure that the new version you deployed is working. After that, it will terminate the old one. Otherwise, it will not terminate. Okay. So let's suppose I will test something. I will change the image tag. That does not exist, and I will apply. You will see here. My old application is still working, but there is issue with my new application. There is no image like this. So that is how Kubernetes will make sure your applications are working, auto-scaled, highly available. And if I click on my old application, you will see here, see welcome, I hope you are getting my words. This is the old version, remember, which were deployed before this one. I'll just do this and apply this. See, if there is nothing changed, it will not redeploy the application. But if there is something changed, in that case only, Kubernetes will update them. Okay, now what we need? We need service, remember? So you can create a separate file for service also. For this demo, I am just using the same file. You can do this. I have snippet, or no need for snippet. You can copy paste from here. See, okay. Or let's suppose if I want to use snippet, you will write here service. Click here, it will create a service for you. Let's use this one. It's the same thing. Let's use this one. Okay, what's the service name? Service name is, let's suppose we will say web app. What is the selector label? Our selector labels are app nginx. So app nginx. Which kind of service you need? Okay, we have three type of servers. Service. Cluster IP is mean that service is only available internal. Load balancer mean that service it will be exposed direct to public. Node port mean that service exposed to public with the node. Let's suppose 5821. So let's suppose your IP is 192 something colon 56821. That is node port. But the best practices for services is use cluster IP because we will use load balancer in ingress. That will come later. So I'll create a cluster IP. If you will not mention, by default it is cluster IP. Name of the port, you can write any name. Let's suppose HTTP port. What's the port of service? I want to access my service on port 80. What's the target port? Target port in this case, this image is running inside on 9000. Okay, so I will use the 9000 target port. So Kubernetes is intelligent. It will only apply those changes which is not there. See, deployment is unchanged. Service is created. I need to do something because I created the service without namespace. So I'll come up here, write namespace. Namespace is web. Let me delete the service from default one. You will do mistakes sometime, but you will understand. Okay, let me come back to my web service. Okay, currently there is no service. I will create a service. So you will see the service is here. And if you need to see the service is working, then you will have endpoints. You will see there are 3-4 endpoints. So this service, it is based on my selector labels connected with my deployment, mean my pods. So if I will now come up here and run this service, okay, you will just check the name now. You will see because it will automatically load balance the request to different ports. Okay. Just refresh hard. If you will put more load, then at that time, currently all of our requests are managed there. But if we will put more load, you will find it here. It will go to another one. So that's the meaning of service. Automatically, it will send traffic to all of them. If one is busy, it will send to second. If second is busy, it will send to. It's kind of load balancing. So Kubernetes automatically load balance your this one. So I can't make more requests from browsers, but if you will test it from script or CLI, you will see the different response here because the response it will come from the other one. Maybe like this it will work. I don't know. No. Okay. But if you will generate more load, automatically the service it will distribute your traffic to all of the ports. That is service. So we covered pod, deployment, stateful, set, service. What's needed now? Let's go and first use the persistence volume, storage in our deployment. Let's see how much easy it is to cover. Let's suppose I want to volume mount. Just click here and it will do the stuff for you. Okay, name of volume, test volume, path is /temp. Okay, before that, okay, I will decrease my replicas to 1 and I will comment this one. I'll just explain you what I am doing. Okay, you can see here my replicas are decreased. I can enable, increase, decrease, do everything. So if I will go to my shell, okay, I will go to cd temp tmp, okay, and if I do ls here, and let's suppose abc.test, I created one file here. You see the file here, right? abc.test. I will come and delete this application. This application automatically restarted. Why? Because it is managed by deployment. Deployment will making sure there will be every time one replica of this board. That's why it automatically get restarted. Let's suppose it get restarted or or you delete or something. After that, let's go inside shell. Let's go to temp path again. ls. You see your data, the file which you write, it's not there because it is stateless. We didn't mount this stuff anywhere. So let's go and mount this path. Okay, I want to mount this path. Temp. Volume name is temp. This one. Okay. First thing this one. Then after that, if you will use autocomplete, you can see here. So see. So you have different type of ways how to mount volumes. One is host path. You want to mount the volume on the host in my system. Then you can use NFS, you can use cloud providers, cloud storages, blob storages, everything is there. Then there is one volume called empty dir. Empty dir is what it is. Empty dir mean again it's a virtual volume. Empty dir you can check for this also here. Okay. Or let's suppose if I will just show you here. Mm, maybe it's here 1 minute. It's kind of this stuff. See, it will be something like this. Empty dir. Empty dir, what this mean? That this is a temporary storage. So in case your application get crashed, only get crashed, your data will not be lost. But if you terminate, it will be lost. This is mean empty dir. Empty dir it have different use cases that is not needed now, but once you get some hand-ons, you will know where to use empty dir because you can share your volumes between different applications. So let's suppose I will just close this one. So let's suppose currently there is only one container. Remember I told you you can create 2 container, 3 container, how many containers you want, you can create it. And then share the volume with all containers through empty dir or even the host path or persistence volume, anything you can do that. Okay, in container there is one more thing in deployments and stateful everything. You have containers, remember? But other than that, you have init containers as well also. You can search for it, init containers. It's something like this. Init containers. What they do, it's the same stuff, name, image, everything is same. Everything is same for these containers also. Just one thing, init containers, once they do their job, let's suppose you run some command You have one init container that let's suppose it will see, okay, before your application start, let's suppose before your this web application start, you have one init container. It can do, let's suppose if you have a Django app, it can in my init container can check, okay, if the Postgres server or database servers it's reachable or no, or to run migrations or to copy some files. This kind of jobs the init containers do. So because once they complete their job, the init containers they delete it by themselves. Let's suppose, let me try to create one init container for you. Let's suppose name test image, maybe busy box if they have, and then you can use the command. Okay, let's try this one. Let's see if it works. Okay, lowercase. Init spec, init containers. We need to see if we are missing something. Low name. Okay, volume name. It is showing some error for the volume name. Sorry, we didn't mount it. So let me quickly mount it. Okay, I don't. Okay, 1 minute. Let me comment this out because let me show you the init containers also. So I created it. So you see, your new application is running now, and it have two containers. Remember? See, and if you will see here, you can see for both. Let's suppose for test, this is the test container which we created, which is what it's doing. It's just sleep for 36 seconds and then after that it will delete. You can see here this container is running. Nginx it's not started yet, but your init container it's running. So init container after 36 seconds you will see init container it will be finished. It will be terminated automatically and your application will run. So init containers what you use for configurations, checking connectivity, this kind of stuff. So let's let it finish. Total 60 seconds are done. It will use 36 seconds. I will just make it more less. Let's suppose I will make it for 30. Just I will update to just demonstrate so that you can see. Okay, this is our new deployment. Our init container is working and it is sleeping for 30 seconds. It can do anything. But once this time is period is done, it will terminate and it will move. Okay, you will see here that that container it's exited. You will see here this test container which was doing this, it is terminated, completed. So this is the job for init containers. Okay, let me just remove this one. Okay, let's go and play with the volumes. So I told you volume have different stuff. You have mtdr type. mtdr it's just for temporary storage. Okay, if your application get crashed it will be there, otherwise if you will delete it will be deleted. Okay, then you will have host path also. Let's suppose volume name is what? Volume name is test volume which you mentioned here, and where you want to mount it. Let's suppose I don't know where I can mount it. Let's see if this work or not. Okay, looks like this is working and we can see here. Okay, mounts. The temp path is mounted from test volume, and if you will come up here. Okay, it doesn't create any volume because we are directly mounting it to host path. Okay, it works. empty dir it will also work. But let's move to a professional one. Professional one means let's create a storage and use it. So first of all, let's you can have multiple also. I'm just doing multiple, but you can create multiple files as well also. So I have autocomplete, or I can use just, let's suppose I want to create persistence volume claim. I can use this code also, or I can use the autocomplete also. Persistence volume claim. Okay, what's my volume name? Volume name is web data. Labels. Remember the labels. Labels are very important. So label you will put it here. Okay. Storage class again. If you will put mention any class, otherwise the default will be used. Read write once, and how many data you want. Let's suppose 1 GB, and the namespace is web. Okay. Let's see what this will do. Let me comment this out. Okay, I will create. You can see here the persistence volume claim is created and other things are unchanged. So in my namespace, if I will come up here, you can see here I created the volume claim, remember? So it's different. Maybe you are confusing. In deployments, we need to mention explicitly under the volumes, okay, use this volume claim. But on the stateful set, remember we use the stateful set. Stateful set, it will give you to use the template directly here rather than creating a separate this stuff. Because deployment, it's not meant for the volumes. Deployments are stateless. But if you want to store data, you can use volume also. But the stateful set, it's for mainly for the data persistency, and that's why they give directly in the manifest file that you can use it directly here. Okay, we use with the stateful set. Remember, let's use it with the deployment. So you created a one volume claim. You can just use the autocomplete or use the template from here. Just change the name, web name, labels as you know how much data you want. That will create a persistence volume. Okay, you can see the persistence volume claim. It's claim. Now this claim means some application will claim this volume and then it will create that stuff. So if you will go here, you will see the volume it's created automatically. Who created this volume? We didn't create this volume. We just request it. The storage class, this storage class automatically create this volume. How the storage class create this volume? Because we created a claim. Claim mean to tell storage class that create a volume of 1 GB in the system, and it creates a volume of 1 GB in the system. You can see it's linked with this claim. But currently this volume it's not used with anyone. So how we can make it use? First thing you need to do volume mounts. Volume mount mean inside container which directory you want to mount, and then other side on the volumes you can just use it, and then you can mention here. Let's suppose I want to use persistence volume. I don't know the syntax. Let's go through the documentation also. Come up here and type volumes. You will find 2-3 links. It's with the practice you will find the right link. So I open the first one and I know some syntax. So I will use something volume mounts. No, 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 not volume mounts. It's sort of volumes. See, you can, it's different options you can explore. But main concept is to let you know that what are the things. See, okay, this is what we need. We need to use claim. Okay, we have name. Okay, and then with the name we have this stuff, and I will put it under. Again, it's an array. You can use multiple one. Okay. So I tell them this volume which we mounted inside, it's coming from the persistence volume claim. Okay. For now, I will tell you, you have empty dep volume also, which is temporary. You can host path. You can mount external volumes. You can mount NFS, any kind of stuff, and then you can mount these persistence volume claims also. You can mount even the config maps, secrets, everything that we will see later. So let's go and see. Okay, what's my claim name? My claim name is web data. Web data. Okay, and I will create a deployment. You can see here my this volume it's consumed with my Nginx application, this web application. And if I will see here, you can see the test volume it's coming from persistence volume, this one. What this mean is I will go to shell, I will go to temp directory, and I will touch hello, hello it's there, and I will delete. Let's suppose my application is deleted or something. Okay, and I go back again to my application cd temp. You will see here the data is still there. That is what's meaning of persistency. That's how we can mount any volume from system volume, empty dir, host path, config map, secrets. You can do a lot of stuff. That is how you can mount something. Okay. Now let me just go quickly and delete this one, deployment. So it's deleted, right? Port, there is nothing port, no deployments, there is no persistent volume claim, no persistence volume, nothing, right? Everything is gone. But let's suppose instead of deployment, if you will use stateful set, let me see if this work directly or okay. See, in deployment you have different naming conventions, but in stateful set you have this sort of naming convention -0. Okay, it's under stateful sets. Okay, and you can see here our persistence volume, it's linked, everything is great. I will go to my temp directly which I mounted, and I touch something hello. Okay, and I will delete this application because it's a replica set. You will see here, and you can increase again, you can increase decrease the replicas, and you can configure here how you are going to update, rolling updates, black box, these kind of stuff. Okay, I go to temp again, and you can see here my data is here. Okay, this means the volume is working, right? Now let me go and delete this definitions. Okay, ports is deleted, stateful set also deleted, service also deleted, persistent volume deleted, everything is deleted here also. See, what's the difference? Mainly, what's the difference here? With the deployment and stateful set. In nature, both are same. The only difference is with their what its name, with their persistence. Because if you will see, let's suppose I'll just show you exactly the template for stateful set. You can say that in the stateful set, You don't mention. Okay, one more thing I want to clear with you guys. These I put all of these information like these definitions files for persistence, volume, stateful, service in one file, and then when I apply or delete, it will delete everything. Normally it should be separate. For deployment you have a separate file, service.yml, persistence.yml, these kind of you have different files, and then you will update that only one. The point is, if you will see here in the stateful set, you will have a template like this. And in this template, you didn't find anything. Let me just go and quickly create one replica of 1 GB in namespace web. Let's create this one. I hope it will work. Okay, it's scheduling everything. Just give him a minute. Okay. Oh, sorry, I did something wrong. And also sometimes you can see that you cannot update it. So for that, we'll just remove the deployment. Okay, just 1 minute. This is the volume. Okay, till now it's not created. Okay, I will create this one. Just 1 minute, please. Okay, okay, okay. So my application is working. Remember, you see here the application is working. Stateful sets are working, and if I will parse data, it will put the data also. I delete my stateful set. Okay, the PV is there because I didn't delete it. PV mean persistence volume. I delete this one, and this persistence volume you can see here because I forcibly delete this persistence volume from here, it will be deleted from here also. But in deployment, your persistence volume it's not protected. But in stateful set, your persistence volume is protected. So once you provision, later on we will see when we will start using Helm charts, you will understand this stuff also. For stateful sets, you can just consider one thing in your mind. If your application is stateless, go with deployments. If your application have persistence data, like some sort of database or Redis or RabbitMQ, which is working with multiple nodes, multiple ports, go for stateful set because you will share the data between all of the nodes, and then there are different parameters for read write ones and these kind of, and at the end that data is protected as well. But in case of deployments mainly for the stateless also, but you can mount volume in both of them. In general, both of them almost work same, but stateful set is more for the data oriented applications because the naming convention also of the applications, and then the read and write stuff, and finally the finalizer. There will be some volumes, even you will delete the claim, the volume will still be there. The volume will still be there, mean the volume will not be deleted. Let's suppose if I will search kids volume restriction deletion protected volume. Sorry, it's called protected volume. Protect. So under the persistence volume, you will find the thing for protection also. So under the persistence, you will see here. Okay, 1 minute. Just maybe I can explain you from here. See, reclaim policy. Reclaim policy is for the storage class. It's deleted. Mean you will delete the volumes no matter whatever the thing, but you can configure these options that you want to retain or delete, or what are the things you want to do. See, reclaiming, retain, delete, retain. Retain, what this mean, if I will change this reclaim policy to retain and I will use in my stateful set, and even if I will delete my persistence volume claims, my persistence volume, it will not be deleted. Why? Because it have that volume is protected because of storage class. Currently storage class have policy to delete the volume. But if I will change this policy to retain or reclaim, it will work differently. Let's suppose in case of retain, if I will create the persistence volume claim from here, my persistence volume here, it will not be deleted. That's simple how it is. Just don't mix deployments with stateful set. Just put one thing in mind. If you have a normal application, even with some sort of basic data, like it's storing some data inside or do some stuff, go with deployment. But if your data is important, like something like Postgres, something like Redis, RabbitMQ, go with the stateful. Where your data is more important. Read write actions, these kind of replications, master slave concept, then go with the stateful. Otherwise deployment will work with you. Even the deployment will work with volumes as well also, but not as much high like databases. Okay, I hope I clear, but a lot of things are there, you can further explore it, but that's not a show blocker. Okay, so we have volumes and everything. Let me clean this volume also. Remove the code for init containers. Okay, I need service. Okay, what's the next stuff? Next thing is config maps. Remember, what is config map? Config map is something which is used as environment variable or as file, some stuff in our application. So let's suppose I want to create a config map. You can come up here, create resource, config map. See, you will find the template here directly without anything. You don't need to change anything, just put the name of the config map, namespace, and what are the values you want. Let's suppose I will just copy paste this stuff here without any change. I will just use it directly here. Okay, I will create a config map with name web config, namespace is web, and let me take some value. Okay, let me take message from here. Message is hello world. Okay, let me create this one. You can see here our application is working. That application is, you know what it is stateful set. Let me make it back to deployment. Okay, it will be deleted automatically, or maybe not. Just 1 minute, let me do the cleanup. Yeah, create deployment. Okay, our deployment is created. We have the services. Our application is also running. We are doing proxy forwarding. Everything is great. Welcome. I hope you are getting my words. Okay. And now I go to config maps. Remember we created a config map with web-config, web-config. And this is all the data which we put here. Remember? Message, player, this. You can see this is, you can mount files also here. Let's suppose you have one file script.sh. You can write here script.sh and then put the script here as a config, because later we will see how we'll use that config map in our environment variables, volume mounts, do a lot of stuff with that one. Okay, you can see everything is here. That's great. You can also update the stuff from here. You can change the values, do this kind of stuff here. Okay, I want to do something. Currently my application, it's showing me message of welcome. This message I hard coded in env, but I want to read this environment variable from my config. So how we can do that? Let's try. So I have autocomplete also, but you will find the syntax. Let's suppose env from secret. I will just copy paste it. Okay. You will find this kind of all the information here. Let's suppose you want to use config map. So come up here and click config map. Okay, you will find all the working examples that okay, how we can use config map, what are the ways to use config map, everything whatever you need it. So let's suppose in this one it's created a config map with different files. Okay, let me see where it is using. See, this is how you can use a key from config map. That's what we already copy pasted. See, value from config map. I will just change it to config map. Just do the indentations. That's all. What's the name? Name of the config map. Our config map is web-config. What's the key? For this environment variable, what value you want to set from this config map? You can do this. Let's suppose, let me take message. Let's see if it works or not. Looks like everything is correct. I go to services, stop the old service and run new. Hala. See, hello world. It's coming from where? It's coming from my config map. See, config map. Let's suppose if I will change hello world and welcome and save it. Once I save it, you will see the difference. If it's not auto updated, that's not good. So if you want to see the changes, let me go and delete my port, so that the new port, it will come with the new config map. Okay, and I will just go to my service and proxy forward it. Okay, see, hello world and welcome. Great, it's working. So now we are able to read our config map from our application. See, that's great. So our config map is mounted here, and and we are reading config map is basically for all the configurations. First use case is I am reading my environment variable from config map. There is one more thing also. Rather than let's suppose you don't want to read environment one by one. You can do there is one thing you can mount all of your config as env or all of your secret as env also. Let's suppose there is something for this one, it's called env from. Let's see if it comes. Configure a port, define variables, this one env from. If we will have some example, thus this one, but you will find everything here. It's like this, env from. Okay, I want the complete env from config map. The config map name is web. Okay, let me just comment this out. I am not reading the message. Okay, so I am saying that load env from web. Let's see if it works or not. Okay, there is some syntax issue. Okay, let's resolve it. Okay, syntax issue. Okay, now you will see if you will open this deployment and environments, see, you will find everything here. So my whole config map is loaded as an env here. See, port, message, game, UI, user interface, everything is there. So this is how you can use env from and specific key also, or complete env. The same thing is for the config map secrets also. So secrets and config map both are same. Just secrets, they are encrypted, nothing more. Okay, so yeah, let's do one thing. Let's try to mount some path. Have autocomplete volume path. Okay, the path name is value from config map. This is the volume name which we are saying, and the path is /tmp. And here we need to define sorry, let me fix it. How we can use the volume from there. You will find the information also here for this thing. Say volumes, the same stuff. You understand my point? You can mount your config map also there. Let's suppose, let's try to mount it. Let's see. And then the name. Okay, it should be same because that's how it will be linked. Okay, and our config map is web-config. This process is normally mounting its use for file. Let's suppose you can store some config file in your config map and then you can mount it there. Let's see how it goes. Okay, it's mounted. You can see here the temp it's mounted from config map, value from config map, click on config map, you can see everything here. I will go to sorry, I will go to shell cd temp, see everything is here. Let's suppose, see, this is how you can mount files, variables, anything through config files. Same stuff is for the secret also, but there is just one difference between config file and secret. What's the difference? The difference, it's just the secrets are base 64 encoded, that's all, nothing else. So let's suppose I will create a secret here also. So I have template for secret. Okay, what is first important thing is namespace. Namespace is web. Secret name is web dash secret. You can see here base 64 encrypt. Okay, there are bunch of type of secrets. One is opaque. Opaque is a normal secret to store multiple type of data. Okay, then you have TLS, Docker, different kind of secret types, but all of them are same. Everything is same to use. Most of the time you will be dealing with the opaque secret. So let's suppose I have one secret key. Okay, yeah, I have some secret key and it should be base 64 encoded. So from terminal, how we can encode it? Okay, let me show you one thing. Let's suppose if I want to create the secret now. Okay, you will come up here. You go to secrets. Oh, okay, it's not saved. Sorry. See, the secret is not created. Why? Because it's not base 64. It should be base 64 encoded. Understood my point? So let's suppose I will echo hello and then I port it base 64. I hope it's right. Okay, I put the base 64 for hello. So you can encode it online and you can use echo and then pipe it with base 64. And I will apply it. Okay, it's not right. I did some mistake. I'll just go and check it. kubectl. Okay, before that, for your information, you can create secrets from here also. You can come up here, write the secret name, select the namespace, secret type. You can go with the opaque. Labels you don't need. In the data, let's suppose my secret is this. In the data, you will write. Here you don't need to write the base 64 encoded value because it's already Lens will do your job. Okay, let me try one secret. Okay, I want to create test secret in web and my data is ss values dst, create a secret. See, the secret is created. You can see here it's the base 64 decoded value. Let me just copy it also. And if you want to see, you can, because it's encrypted. If you will click show, it will show you the value what's the real life. Let's suppose I will change the value to hello g hello test. Once I save it, Kubernetes will automatically update it. Understood? I'll just copy use this base 64 to create our secret and I will just delete it. You can use the kubectl secret base 64 encode. So you will find some command here also. Yeah, it's something like this: echo -n, your password, and then the base 64. It will work like this. I did some mistake. Okay, so let me create my secret now. My secret is created. You can see it's base 64 encoded. If I want to view, I see the value hello test. And the same way, I mounted the config map or what its name, volume, volumes, envs, everything from config map. The same thing you can do with the secrets also. So for example, let me do this thing. Let me mount some secret. It's not from config key refer, it's from secret key ref, ccret. What's the secret name? Secret name is web, SCCRET, and the key is secret key. Let me try to run. Okay, it's done. You can see our new deployment, and when you will go to the environments, you will see here we pull one environment from the secret. See the secret. If you want to see, you can click here and you can see the secret value. That's how simple it is to use the secrets configurations for your applications. Mount them, pass them as env, mount them. If one important command maybe you can use is a command. Let's suppose if you want to do something, you can use it. It will override your existing Docker command. You can use it and pipe it with your existing one, something like this. Okay. So we cover all of this almost. We know the service, we know deployments, boards, config maps, secrets, everything. Now the time is for the ingress, how we will expose our application. The same stuff, nothing changed. But for ingress, we need to install something before, some proxy. So I will use ingress nginx. There are a bunch of other options also. You can use Istio, you can use console, you can use Terrific or anything, like any proxy service. So I will just install it. Quickly I will install it from the charts. I will make one separate video for Helm charts also to make the things easy. Okay, and I will just install this. I can install it from definition files also. Definition file mean like this also for ingress. It's same, but or I can install Helm also. I will make one more video to go through in depth for Helm as well. But both are same things. There is nothing changed. Helm is, you can say it's like templating, nothing else. You can pass parameters into these things through values file. It's Helm is for templating, but inside this is the thing. You will find it everywhere. So I will just install my ingress. I need to install ingress. Okay. If you're using any cloud, anything, you need to install ingress there. The best one for now is ingress nginx. Okay, if you will just search for install ingress nginx kits, you will find their link, and you can just git clone, go to this file and apply this thing. That's all. Or if you want to do less work, go to lens charts and install it. Nothing else. Okay, but you need to have ingress, any kind of ingress. It can be nginx, terrific, console, istio, any kind of thing, but it should be there. Because if I will see, I will show you in the default namespace, you can see here the ingress is installed. It's board. Okay, this is our deployment. Okay, it have bunch of config maps and secrets. Okay, everything is same. Important thing is service. You can see it's two of the services. Basically, this service is the normal cluster IP, but one service is load balancer. Remember what I told you for load balancer? Load balancer is for the public access. So let's suppose it exposed to my local host, external now. If I go now to localhost, this is showing me Nginx. So this is coming from where? It's coming from my ingress now. So I have one ingress, mean when I use localhost, my request come up here, ingress, on this level. And it's showing 404 because I didn't put any rule for my application that if someone come this, do this. You understood? But you need to have ingress. Okay, let's go back to our application now. I want to create ingress, right? Again, you can create from here also. Everything you can create from here. Ingress, everything is here. I can just go copy, use it, or I can have the template also. It's on you how you want, or you can get the template directly from here. Simple. Let's suppose if I see, let's suppose if I have, okay, I have ingress. Okay, let's use it. Ingress name, web ingress, namespace web. Okay, this is the host name. This is the public address which you will set up. So let's suppose if someone come foo.power.co, it will redirect to our service on this path. When someone comes on this path, it should connect with our service on port this. Okay, we have what's our service name? Our service name is web app and it's listening on port 80. Port number 80, service name is this. Yes, that's all. Our ingress is created. See here. If you will click on sorry, ingress is, you can see the ingress is created, but it's currently it's not working because it is not showing any load balancers here. I mean, it's not exposed till now anywhere. See what we are missing. Remember at start I discussed with you annotations. That is what we will use now to add the functionality. Through annotation we will define ingress to use the class of Nginx. See, we installed Nginx ingress. Remember? So we will tell our ingress, mean Kubernetes, that for ingress use this class, use Nginx, use Terrific, like it's on us what we put the name. Let's suppose if I go to default and on the config names, okay, it will be defined something. If you will find, okay, it's not here, but when we installing we have the option to set the value what is the class name. So by default its name is Nginx, but you can change it also. But we need to tell our application that okay, create an ingress and use this class. For that there is something called annotations. Okay, let's open their documentation directly, copy paste the stuff. There are a bunch of annotations, like this annotation, what it's doing, it is doing rewriting to this URL, but we don't need this. We need the annotation for class. If I will search it, ingress class name, sometimes it's difficult to find, but it's okay, we'll find it. Here we can open it and see if it's not ingress. Okay, you can define like this also. Bunch of options. Under the spec, you can define it here also. The ingress class name. Or let me show you the annotations. This is how we use annotations. Kubernetes ingress.class. This is the class name. By defaults, which is Nginx ingress we install, it's with the name Nginx. But we can change it. But if you have a separate class, you can use that one. Class mean the installation, which proxy server you want to use. So I installed the Nginx, so I use it. This name is dynamic. While you was installing, you can change it also. Okay, let me do it now, and if you will see here, currently on the ingress, there is no load balancer, nothing, mean it's not working. I will update it now. Okay, it's updated, and you can see it's scheduled for sync. What this mean? This mean is my application, my proxy server, Nginx proxy server, it will update in its configuration that if someone comes with this domain foo.bar.com, then redirect it to this external internal service web app. Okay, let me go and see if it works for me. See why it's working for me, because I add the local host etc host. See, I added here also. Where it is? Yeah, this one. So you can also, for testing, you can do this one local. You can put the local IP 127, and then you can put any domain which you want to resolve. So currently foo.bar.com, it's mean my local host, but there is nothing changed. Let's suppose if it's a real website, let's suppose hello.bytelegends or hello.enterprisedevops.com. Okay, in the cloud where you are managing DNS, you just need to point to your load balancer IP. That will be mentioned here. Currently it's for my local host, but when you will host it to AWS or Azure any cloud, you will get a public IP. That public IP you will put in your DNS under A record or CNAME record, and that will work for you. When you will hit that DNS, the traffic will come here, foo.bar.com, and then we have service. What is the service? We have web app service. That service, it's go web app service. That service, it's connected with ports. It is connected with ports, and it is using PVC, config map, secrets, everything. And that port, it's managed by development deployments. That is everything you need to know about Kubernetes. You don't need to work on the CLI, just use this tool Lens, Docker Desktop, or connect with your current Kubernetes cluster. This session is not for beginners. Everyone, even in the enterprise company, the professionals, they are doing like this. Okay, to be more productive, you just need to go through 1-2 commands here to apply and delete. And that's all. Everything you can manage from here. So these are the core components. Other than that, if you want to explore more, you can visit this kubectl cheat sheet that will help you to run some commands if you want to do some work on from the CLI, and the documentation. Everything is available on the documentation. You can do everything. There are some stuff relevant to the security. Let's suppose quotas. Quotas mean you can assign resources. Then HPA, it's for horizontal pod, autoscaler, then distributions. Okay, and then what's the important one? Important one. Other than that, yeah, that's the thing. Other than that, maybe if you want to explore, you can see the service accounts. Service account cluster roles, cluster, role binding, role bindings. These are all relevant to the security. I'll just go through quickly. Service account, it's basically it's based on the namespace. Okay, a service account, it's like you can say that it's like access token. Okay, that access token, it can be used to access the API of Kubernetes. So let's suppose if your application is running in a pod, and by default it will create a service account which it can use to communicate with the Kubernetes. Let's suppose to read configs or secrets. But if you have a proper restricted service account, that's how you can control the access also. That the service account, it will work only this namespace, not global, this kind of stuff. Then you have cluster roles. Cluster roles, again, it's roles for the whole cluster. It's like global. And the simple roles, they are namespace based. In roles, what you have, and then you have role bindings, cluster role binding and role bindings. One is namespace, one is global. What you have in role. Okay, let's suppose you want to give access to any user or some stuff or any service account, and you link a role. Then you can put permission on that role. That this role, what it can do, it can list resources, it can create deployments, it can delete something, it can do logging, it can execute. All kind of permissions you can configure from these things. Okay, and then CRDs and Helm chart, maybe this we can discuss in some other video. That's all what you need to get started on Kubernetes. Best way is to get used with the lens. Try to create some files from here. Okay, apply the files, see how they are working. And if you need something, you can just come up to documentation. You can find the working application. So take any application and you can run it. Just go for it. Important, these are the important key things which you need to work on. There is nothing complex, it's almost easy. Don't worry about the CLI, just start working from the lens. Create your deployments, deploy your applications, log them, check environment variables, secrets, configs, volumes, everything. That's all what you need. Okay, and yeah, I think so. That's all for this session. And in the upcoming videos, maybe we'll be working on some Helm chart or something. Let me quickly show you some stuff like the power of lens. You already see how much powerful this tool is. And let's suppose you want to quickly deploy WordPress or Odoo or any system. Just come up to charts. You will find almost all of the applications here which you worked on. You can just come up here and deploy it. Let's suppose I want to deploy WordPress. It's very famous. I will click, come up here. Okay, which version I want, these things. This is the values file. This I will discuss when I will make some video for the Helm charts thoroughly, how to create Helm charts, how to use and how to work with Helm charts. Because at the end you will work on Helm charts also. So but Helm chart is nothing, Helm chart, everything it's same definitions files, everything is same. Just Helm file, it will do something like this. We'll create a values file. So you can put values file here that will be used as a template inside this one, like you labels and this thing, anything. You can pass values here as a template. So let me quickly install the WordPress. That's how easy it is. I think it's installed to default namespace. Okay. Yeah. So yeah, we have a deployment. We have some secrets also. We have some services also. A lot of things there. Let's see when it will work. Currently it's, if you want to see what it's doing, you can see from log here. Successfully assigned pulling images. Currently it's pulling the image for the WordPress. I install this application directly from the Helm, just to show you the power of this tool lens. Okay, let it download. Once it's downloaded, you will see your WordPress is up and running. Okay, and we will access the WordPress from here. Okay, it's downloading image. Maybe sometimes it's took time to download the images because they are in sometime in MBs more. So that's how you can do it quickly. Install any of application, go to charts and install it. If you want to delete, you can come and delete it. I will delete both releases, and I will delete my this file also. The final cleanup. So everything is clean now. There is nothing. Everything is terminating now. I will come to my namespace also, and I will terminate this final cleanup. And then after that, disconnect it and quit. That's all for now, and give it a try. But if you have anything, any question or anything, do let me know. Ping me on comments or drop me an email, something. Thanks. Cheers. I'll see you soon.